Okay, so for this video, we'll be discussing the October-November 2023 Probability and Statistics 1 paper 5.1. Okay, so let's have a look for the first question. Alright, so we are given a graph, which is a cumulative frequency graph, and then they are saying that the time taken by 120 children to complete a particular quiz are represented in the cumulative graph. So they want us to use the graph to estimate the interquartile range of the data. So to get the interquartile range, I need actually Q3 minus Q1, right? So I need the value for Q3. I also need the value for Q1. Alright, so first of all, if we want to estimate the value for Q1, I have to take the total frequency, which is 120, multiply with 1 over 4. Because Q1 is actually the data which consists of 25% of the data from 0 until, from the smallest value until Q1. So smallest value until Q1 is actually 25% of the data. Therefore, I use 120 multiply with 1 over 4. So from here, I get 30. So that means for Q1, you need to read the value from 30 itself. Okay, at the cumulative frequency axis. Then for Q3, you have to take 120 multiply with 3 over 4, which is actually equals to 90, the value of 90, right? So again, for Q3, it consists of 75% of the data from smallest value to that particular value Q3. Okay, so that's why you need to multiply 1 over 4 and also 3 over 4. Alright, so after you know the value already, you can start reading the value from the diagram or from the graph. So I'm looking for 30 from cumulative frequency axis. So 30 should be here. Alright, so you can try to draw a line towards the graph and reflect it down to the x-axis. Okay, so if you try to read the value from the axis here, so look at the ratio lah. So approximately I get actually the value 24. Alright, so this is my Q1 actually. Then after that I want to get the Q3. So for Q3 I will read it from 90, the value of 90, cumulative frequency 90. So again, trying to draw a line towards the graph, then reflect it downwards to the x-axis. And after that, read the value from the ratio, the scale. So if you have a look, right, so this value, I think should be 31. Okay, for me, myself, I think I get 31. Alright, so since you already get the value for Q3 and also Q1, so we can continue further to find out the interquartile range. Okay, so the interquartile range will be equals to Q3 minus Q1, as what we know. Then what is Q3? So Q3 is 31 minus 24, and it is equals to 7. Okay, so just take note that when you are reading the value from the graph, right, it might be there must be some difference, a small difference between people to people. Okay, so please have a look for your final answer, whether it lies inside the range provided in the marking scheme or not. Right? Okay, so let's continue to part number B. So for part number B, they are saying that 35% of the children take longer than t seconds to complete the puzzle. So they want to estimate the value of t. Alright, so for this question, right, when we are having any cumulative frequency graph, you need to know that the value provided in the graph is given the value which is shorter than something or less than something. So when they are saying 35% is longer than t seconds, to estimate the value, we actually have to change it become a phrase, okay, or maybe the percentage that's less than t second. That only you can get the value from the graph. Alright, so this is longer than means more than, alright? Longer than means more than. So if let's say I'm having 35% takes longer than t seconds, is having actually the same meaning as 65% of the children or maybe the students take less than t seconds to complete the puzzle. Okay, so these two sentences basically is having the same meaning, right? 35% more than t also have the meaning that 65% less than t. Okay, so to estimate the value from the diagram, I have to use the 65% instead of the 35, because for cumulative frequency graph, they always give us the information about less than. All right, so we cannot estimate any longer than value. So we can only estimate less than, right? So 65% takes less than t seconds. So I have to take 120 multiply with 65%. So you get 78. All right. So what does it mean? That means you need to get the value of t, you need to read it from the graph again. Okay, from the cumulative frequency exists on 78. Right. So let's proceed further. So where is 78? It should be somewhere here. This is 78. So again, we do the same thing like just now. You try to get the line, okay, towards to the curve, and then reflect it downwards. So if you try to reflect it downwards, so what's the value that you get? So that will be the value of t. Okay, so if you have a value from here, read the value from here, I think it should be 28.5. Okay, right. So straight away you can write out your answer in the space. Yeah. So your t is actually equals to 28.5 seconds. Okay, so this is how we answer question number 1. Okay, so let's discuss question number 2. Right, so Hazim repeatedly throws two ordinary fair six-sided dice, okay, at the same time. Then on each occasion, the score is the sum of the two numbers that she obtains. So the sum of the two numbers. She's throwing two dice, and then they are fair six-sided dice. Okay, then the score is actually the sum of the two numbers. Then they want us to find the probability that it takes exactly 5 throws of the two dice for Hazim to obtain a score of 8 or more. Okay, all right. So maybe first of all, right, we have to focus on this one first. She wants to obtain a score of 8 or more. So we need to find out this probability first before we can continue to find out some other probability that is requested by the question. Okay, so now let us focus on this one first. If she's throwing two fair six-sided dice, and I want to know what's the probability of obtaining a score of 8 or more. So there are many ways for you to find out the probability. Then for me to make sure that I didn't miss out any single value, so usually for me I prefer to use probability space diagram. So that means I need to list out all the possible value, okay, for six-sided dice. So what I do is something like this. Okay, so I'm having 1, 2, 3, 4, 5, 6. Let's say this is dice number 1. Then 1, 2, 3, 4, 5, 6. This is dice number 2. Okay, alright, so when I'm having two dice, so I can draw this probability space diagram and to show all the possible value. Okay, so some students might ask that, oh, can I use some other method to find out this probability? Of course you can. Alright, but usually for me, when I'm having like two dice, two coins, and I don't want to miss out any possible result, so usually I would prefer to draw the probability space diagram. Okay, so all this inside, you're having 36 result here. Okay, all the 36 result here, it actually shows all the possible result that you can get when you throw the two fair dice. Okay, so let's have a look. For this question, they're asking for a score of 8 or more. How to get the score? The score is sum of the two numbers. So as an example, if let's say I refer to this particular cell, right? So this particular cell, the score is 2 plus 1, which is equals to 3. Okay, so this is what we have for the score in this question. They are talking about the sum of the two numbers, right? Okay, so now let us figure out in which cell actually it belongs to the score equals to 8 or more. Okay, so of course for the first row, if we have add 1 plus 1 is a 2, then 2 plus 1 is a 3, all this doesn't fulfill the condition where you want to have the 8, the score is 8 or more than 8. Okay, because 1 plus 6 also 7 only, right? So all the first column here, there's none of the result that fulfill the outcome that we want. Okay, then for the second column here,
2 plus 1 is a 3. Maybe you come to the last one, 6 plus 2, you get an 8. So that means on this particular cell is something that you want. Alright, then after that for the third column, 3 plus 1 you get a 4, 3 plus 2 you get a 5. So if you glance through again, scan through again, maybe at this part 5 plus 3 you get an 8. So they want to have the score 8 or more, right? So 8 is included, therefore this is the cell that I want to consider. Then 6 plus 3 also. Okay, so if you slowly go through all the single cell, every single cell here, you realize that all these are the score that I want. So like this one, 5 plus 3 is an 8, then 5 plus 4 is a 9, and so on. Then 6 plus 2 is an 8. Okay, so all the cell with tick actually fulfills the result that we want, where it is a score of 8 or more. Alright, so to get the probability, when you draw the possibility space diagram, you can just count how many cells that you want out of the total cell. So if you count all the black color tick here, you should see that I'm having 15 cells with black color ticks divided by the total outcome. So the total outcome will be 6 times 6, which is 36. So you can further simplify them, become 5 over 12. Okay, alright, so this is the probability where our score is 8 or more. But now in this question, basically they want us to find out the probability that it takes exactly 5 throws of the 2 dice to obtain the score for 8 or more. Okay, exactly 5 throws. And then when you read the question at the beginning, okay, repeatedly throw 2 ordinary fair dice, 6-sided dice at the same time. On each occasion, the score is the sum of the 2 numbers that she obtains. Okay, then after that, they say, when she throw it repeatedly, right? When she throw it repeatedly, okay, she get the score, okay, the score of 8 or more, exactly at the 5 throws. That means exactly 5 throws, which means that maybe the first row, okay, first row is not the score of 8 or more. Then second throw also not the score of 8 or more. Third throw also not. Fourth throw also not. But the fifth throw, she finally get a score of 8 or more. Okay, so when you're having this kind of question, right, when you repeat to apply, or maybe you repeat to run through the experiment until you get a result that you want, basically we call it as geometric distribution. Okay, something is done repeatedly, okay, until you get the result that you want. So we call it as geometric distribution. So this question actually has that meaning, all right? So X is geometric distributed. What is the P, the probability for the geometric distribution here? So basically it's a probability that we get the score of 8 or more. So it will be 5 over 12. And they are asking for the probability of X equals to 5. Exactly 5 throws, so the number of throws equals to 5. Okay, so which means that the first 4 throws, they are not obtaining the 8 or more. So if let's say first throw you didn't obtain 8 or more, so it will be 7 over 12 lah, which is the opposite of this one, right? Then for the second throw, also not obtaining 8 or more. Third throw also not. Fourth throw also not. And finally the fifth throw, you get the score 8 or more, which is 5 over 12. Alright, so if you try to simplify this, then basically you will have 0.0482. Correct to 3 significant figure. Okay, so let's proceed to part 2, part B. For part B, they want us to find the probability that it takes no more than 4 throws of the 2 dice to obtain a score of 8 or more. So again, for this question, it still belongs to geometric distribution and we are still focusing on obtaining the score of 8 or more. Okay, so X is still geometric distributed where the P is 5 over 12. Okay, so they are saying that the number of throws is no more than 4. That means X should be smaller than 4 or equals to 4 no more than. So no more than means that it can be equals to 4 or less than 4. So it should be smaller equal sign. Okay, then how can I calculate the probability here? So there are two methods for you to find out this answer. The first one is you try to find out the probability one by one. So that means the number of throws smaller than 4 or smaller equals to 4 means that you can have x equals to 1. That means when you throw once for the two dice, right, you already get the result that you want. Or you might have the number of throw equals to 2. That means when you throw for the first time, you didn't get the score 8 or more. But when you throw for the second time, you get the score 8 or more. Okay, then you can have also x equals to 3 and also x equals to 4. Okay, so for x equals to 1 means that for the first throw, you already get the result that you want. So the probability will be 5 over 12. Okay, so for x equals to 2, so for x equals to 2 here, the first throw, you didn't get the result that you want. So it should be 7 over 12. And after that, the second throw, you get the result that you want. So it will be 5 over 12. Okay, so that's the ability for x equals to 2 lah. Then x equals to 3, what is it? So the first two throw, you didn't get the result that you want. So you can write it as 7 over 12 power 2. Then multiply with the last time you get the result that you want, so 5 over 12. Then when x equals to 4, it means that 7 over 12 power 3. The first 3 times you didn't get the result that you want. Then the last time you get the result that you want. Okay, so basically this is how we set up the question, and after that, by pressing calculator, try to simplify and get the answer. So if you didn't do any careless mistake, by right, this answer that you obtain should be 0.884, correct to 3 significant figure. Okay, so for this question, right, we can still try to find out the probability by listing out the value one by one. Okay, because the x equals to 4 is not too large. Alright, but somehow in some of the question, right, if they're asking for x smaller equals to a very large number, as example, like x smaller equals to 20 or x smaller equals to 15, so it is quite not practical for us to list out all the value one by one and press calculator one by one. So for this kind of question, right, actually there's a shortcut or maybe a general formula that we can apply here. Okay, so what's the general formula? So we're having a formula that you can apply directly where when you're having x smaller equals to r, the shortcut formula is actually 1 minus q power r. Okay, so especially if the value of r is very large, then it is very useful for this example. Okay, so like this question, the r is 4, so 4 to me is not too large yet, not too big yet, so it's still possible for us to list out the cases one by one. Okay, so if I want to apply this formula, make sure that you're always aware that the r, right, it should be smaller equals to r, must include the equal sign. Okay, all right, so for this question, if I want to apply this formula, this general formula, so it will become x smaller equals to 4, where it is actually 1 minus q. Q is what? This is p, right? 5 over 12 is a p, so q should be 7 over 12 and then power 4. So if you try to simplify again, you realize that the answer is the same, 0.884, correct to 3 significant figure. And you can also observe that this particular formula gives you a very short and simple steps. Okay, and they lead you to the correct final answer. Okay, so especially for the value of r which is very large, then this formula is very useful. Okay, so maybe you can remember it. Alright, okay, then let's proceed to question number C, part C. Okay, so for part C, now instead of repeating throwing the two dices, right, now they are mentioning that I now throw eight randomly chosen throws. That means I choose 8 of the throws for the two dice, then find the probability that they obtain a score of 8 or more fewer than 3 times, fewer than 3 occasions. So just now for part A and part B, if you try to observe the question, they are repeating throwing the two dice until you get the result that you want. For this question, they already have a fixed limit. That means you're having 8 throws, and then fewer than 3 throws, something happen. So for this kind of structure, with a limit, okay, of the number of trial, it is actually binomial distributed. So I hope that you actually can observe the pattern and then aware that this is binomial distributed for part C. So now if I let x equals to the number of throw, right, obtain a score more than of 8 or more, is binomial distributed with the total number of trial is 8, And then the probability is still the score of 8 and more. So it should be 5 over 12. And for this question, they are looking for the probability of x fewer than 3. So it should be smaller than 3. Okay, so for your understanding, right? If let's say I want to find the probability for x smaller than 3, for a binomial distribution, you can start from 0. Where out of the 8 rows, there's no row obtain the score of 8 or more. It can be also x equals to 1. Okay, it can be also x equals to 2. So for our question here, right, in the formula that we get in the solution that we set up just now, they're asking for x smaller than 3, which does not include the 3. So by right, we should stop at x equals to 2 lah. Okay, then after that, how to find the probability for x equals to 0? It will be NCR. So n is 8, C is C lah, R is 0. Okay, our R is this one, the number of x. Then P power R. So this is my P power R, which is 0. And then Q. Q is 7 over 12 power N, which is the 8. Okay, then this is for the probability of x equals to 0 lah. Then after that, you can find out the probability for x equals to 1. So 8C1 P power 1 Q power 7. Then 8C2 P power 2 and also Q power 6. Alright, then after you list out the general formula for the probability by substituting all the value. Okay, so if you didn't do any careless mistake, by right, you should have 0.282 correct to 3 significant figure. Okay, so you can see that for this question number 2, right, geometric distribution and also binomial, usually you won't see the keyword very clearly. So you just need to bear in mind that, oh, for geometric distribution, the experiment is repeated until you get the result that you want. So usually that belongs to geometric distribution. And then for binomial is, you are having a fixed number of experiment, and then they're asking for the probability of a smaller number of experiment happen, something happen to the smaller number of experiment. So as an example, this one is the 8 experiment we have, then fewer than 3 experiments, something happen. So it belongs to binomial distribution. Okay, right, so this is how we solve question number 2. Okay, so we are at question number 3 now. So there's a farmer sells egg, and then the weight in grams for the eggs are modeled by a normal distribution. So please highlight the keyword normal distribution. They also give us the mean and also standard deviation at the same time. So the eggs are classified as small, medium, or large according to their weight. So a small egg weight less than 76 grams, and also a small egg, so they define the small eggs weighs less than 76. So if let's say your eggs are less than 76 grams, then basically it belongs to the small egg. Then 40% of the eggs are classified as medium. So first part, they want to find the percentage of eggs that are classified as small. Okay, so again, let us define x as the weight of the eggs. So x is normally distributed because you see the keyword, right? Normal distribution. So x is normally distributed with the mean 80.5 and also the standard deviation 6.6. So you want to put a variance here, right? So you put it as 6.6 square. Then they want us to calculate the probability for eggs that are classified as small. So just now in the question, they did tell us that small eggs weight less than 76. So that means you want to find the probability where x is less than 76. Okay, so since this is a normal distribution, right? So to find the probability, basically you need to change it become z. You have to standardize your x become z. So how to standardize your value from x become z? So you have to take the original value of x, which is 76, minus the mean. So minus 80.5 divided by standard deviation. So what's the standard deviation here? 6.6. So divided by 6.6. Okay, then you'll get the value of z here. Alright, so please make sure that you write out the step of standardization, and usually you will be given marks. Okay, right, so when you know that you need to standardize it become the value of z. So if you didn't do any careless mistake, right, the value of z should be 0.682. And again, for the value of z here, please find out the value up to 3 decimal places, because in our normal distribution table later, right, we're able to find out the probability for the Z value up to 3 decimal places. Okay, so to get the most accurate answer, please keep it up to 3 decimal places. Okay, so Z smaller than 0.682. If you observe the area that we want to find, if this is 0 in the center, so this is the area that I want to find, where it is 0.682 negative. So this particular area basically will be the same as the area on the right hand side, 0.682. So the red color and blue color should be the same value. Okay, so to find out the area for this blue color, you have to take 1 minus the probability of Z smaller than 0.682. Okay, so we can get this value from the normal distribution table when Z is smaller than a number. Okay, so please have a look for 0.682. Let's go to our table here. 0.682, right? Okay, so 0.6 is here. This is 0.6. And then 8, where's the 8? This one. So the value that you get is this 7517. So 6, 8, 2. So I need a 2. So where's the 2 here? This one. So for the 2, you need to actually add the 7 to the last digit, which means that you take 7517 plus 7. So you have 7524. Okay, so we go back to our question here. So you should take 1 minus the probability of 0.7524. So you get the value 0.7524, right? Okay, so if you take 1 minus, you'll get 0.2476. And for me, I prefer to keep it to 3 significant figures according to the requirement in the question. So it will be 0.248, correct to 3 significant figure. Alright, yeah, so this is what you have for part A. And for part A, because the probability that the number that we found here is the probability. But if you read the question very carefully, right, they're asking for percentage. So we actually need to change become percentage. So just one step extra. Please write out the percentage here. It should be equals to 24.8%. Alright, so this is how we solve this part A for question number 3. So let's proceed to part number B. Okay, so for part number B, they want you to find the least value weight of an egg classified as large. Okay, so if let's say I have the eggs, so the small one means that it must be weight less than 76. The medium one, okay, the medium one, I don't know what's the limit, it should be between 76 until a value here. And when you are having a value more than the L, so we will consider it as large. So for this question, right, they're asking for least possible weight of an egg classified as large. So the least possible weight will be the L. Okay, that means if any eggs weight more than L, then we consider it as a large egg. Okay, then how can we find out the value of L? So I actually need to have all the probability here. So for the small one, right, just now I know that 24.8% considered as small egg, 40%, okay, of the eggs considered as medium. So what is the value for large egg here? So to get the percentage of large egg, you know that you should take 100% minus 24.8 minus 40. Okay, so since we know the percentage already, then we can use the percentage to help us to find out the value of L. Okay, so first of all, I will want to take a percentage of large egg. It will be equals to 100%. Then you minus 24.8%. And you minus 40% again. And I want to know what is the percentage here. So by right, it should be, okay, so maybe for this one, right, the 24.8%, original value that I get just now, right, is 2476. So I think I want to use back the most accurate answer. So instead of using 24.8 here, I will use 24.76. Okay, if I try to minus all this, right, then basically I'm having 35.24%. Okay, so the 35.24%, you know that if I change become probability, it should be 0.3524 lah, divided by 100. Okay, so what does it mean? That means the probability that the egg classified as a large egg is equal to 0.3524. Okay, so by using this percentage of probability, I want to find out my value of L. Alright, so again, let's proceed further. So again, X is still normally distributed, so I have to change it become Z first. So I need to standardize it where I take L minus the mean divided by standard deviation. And it is equals to 0.3524. Okay, so to find out the value of L, right, if I try to observe this whole equation here, and I try to draw it by using a normal curve, by right, 0.3524 is a small area. And they said they want to have Z greater than this value is a small area. So that means by right, your graph should look something like this, where this value here will be your L minus 80.5 divided by 6.6. And I want to know what is this particular value here. Okay, because I already know the area, which is 0.3524 lah. If you try to observe 0.3524, this is probability. So if you try to have a look for your normal table, you won't see any 3524 from this part. All these are probability. You want to find it backward. Okay, so 3524, you realize, hey, there's nothing 3524. You cannot see any 3524 from this part. So how can you continue further from here? So instead of using 3524, you should actually use 1 minus 0.3524. And the value that you get should be 0. Sorry, you can take 1 minus 0.3524. Sorry, let me calculate what is the value out. So 1 minus 0.3524. You should get 6476. Okay, so that means instead of finding the value by using 3524, please use 6476, finding backward. Alright, so to find out backward, okay, so looking for 6476, right? So where's the 6476? Okay, so please find out the value from the probability part. So the probability part is somewhere inside here. So look for a value smaller than 6476 but closest to it. 6476 should be 6443. Because 6480 already more than 6476, so I should use this one. 6443. So what is the value of Z for 6443 here? It is equals to 0.37. Okay, then to make it become 6476, how many unit or how many value you need to add to get 6476? So you take 6476 minus 6443, so you get 33 here. So please have a look at the back here. Is there any 33? There's no 33. So for me, I will take the value which is closest to 33. So I will take 34 here. So the last digit of the Z value will be 9. So if you try to read all this value here, you will realize that your Z is 0.379. Okay, so 0.379, Come back to our steps here. Okay, this is my value of Z, right? So I know that my Z is this one. It should be equals to the Z that I found out from the table just now, which is 0.379. And then before I decide this value, right? This value I get it from the table, then I need to have a look. Okay, have a look for my graph, and you realize that, okay, my Z is on the right hand side of the graph. It is not on the left. So if right hand side means it is a positive value, therefore this value should be positive 0.379. If you draw your graph and you realize that your Z is on this side, then the value that you take just now from the table, you have to put a negative in front. Okay, so for our case here, the graph is on the right, so I just keep it as positive value. So from here, if you try to rephrase your equation very slowly, then you should be able to get 83.0014, something like that. Okay, then again, correct the three significant figure, it should be 83.0 grams. So that means any eggs weight more than 83.0 grams, so we classify it as a large egg. Okay, yeah, so this is part B. Then let's continue to part number C. Okay, so for part number C, I'm now having 150 of the eggs. Then they want us to find more than 68 of the egg, 68 of the eggs, something happened. Okay, so again, you can see the structure here. I'm having 150, that means a bigger number of eggs. And then more than 68 of them, something happened. So this kind of structure belongs to what? Belongs to binomial again. Right? So now I will put it as y. So y is the number of eggs. Okay, so y is binomial distributed with 150 eggs in total. And then what's the p that I should put in here? You have to put in the probability where it is classified as medium. So what's the probability for medium just now? 40%. So you should put it as 0.40. And for this question, you can see a very obvious keyword, approximation. So that means you can change binomial, become some other thing else to make our calculation easier. So in our syllabus, binomial can be changed into normal distribution. Okay, but of course, you need to fulfill three conditions, right? Where n greater equals to 30, np smaller, np greater than 5, and q also greater than 5. So when they ask you to use approximation, right, basically it means that all the three conditions are fulfilled. Then only they will ask you to change binomial become normal. Alright, so to find out the normal parameter, right, this one, the first value should be a mean. So how to get the mean for binomial distribution? So it should be 150 multiplied with 0.4. So you should get a 60. Okay, so just to remind you all, so to get the mean, it is actually NP, which is 150 multiplied with 0.4. Okay, then how to calculate a variance from binomial distribution? It should be NPQ. So when you take NPQ, it should be 36. So just to remind again, so from binomial distribution, if you want to get variance, it should be NPQ, where it is equals to 150 multiplied with 0.4 multiplied with 0.6. Sorry, 0.6 here. Okay, all right. So after I change it become normal distribution, so I can start calculating the probability. So I'm looking for the probability of x more than 68. So y more than 68. Okay, so since this is a normal distribution now, originally it is binomial, right? So from binomial, when you want to change it become normal, you have to apply continuity correction. Okay, so for the continuity correction of this case, it should be more than 68.5. If you need to know why our continuity correction is 68.5, maybe you can have a look for my other video in the lecture part, the lecture playlist, which is chapter 5. Okay, so you can have a look from the video from that playlist. So I actually did explain further on why we add 0.5 for this case. Alright. Okay, then after that, after your continuity correction, so this is the step for continuity correction. So since you know that it is normal distributed, so you have to standardize it, change it become z. So I'm having the value of y minus the mean, so minus 60 divided by standard deviation, so divided by square root 36. 36 is a variance, so standard deviation means square root 36. Okay, so again, for the same rules here, the value of z, please find it up to 3 decimal places, so it should be 1.417. To get the probability of 1.417, right? Okay, this is the area that I want to find. Let's say this is 1.417. This is the area that I want to find. But for normal distribution table, they only provide us the area smaller than 1.417. So to find out the probability for this particular area, it should be 1 minus z smaller than 1.417. So go to the table again, look for 1.4. So look for the value of z first. Okay, 1.4 is this one. 1.41 should be this. And then 7, where's the 7? This one. So by right, if you have a look for the value, you should take 9207 plus 10 at the last two digits. So 9207 plus 10, you should have 9217. So you have to take 1 minus 0.9217. And from here, simplify your answer. You should get it correct to three significant figure 0.0783. Okay, all right, so this is how we find out the answer for question number 3. Okay, so now we come to question number 4. We are given a table, right, that that is related to the time to the nearest minute of 150 athletes taking part in the charity run. So these are the results. Okay, so we are having time in minutes and also frequency in the distribution table. Frequency distribution table. Okay, so first they want us to draw a histogram to represent this information. Right, so to sketch the histogram, if you try to observe all these classes, yeah, okay, so you realize that they are having different width actually. Okay, so maybe you need to know what is the class boundary first. So if you double check with the value here, this upper limit is 120 and the lower limit for the next class is 121. So there's a gap between them. Therefore, you have to do some adjustment to get the class boundaries, where you have to take the lower limit minus 0.5 become 100.5. Then for the first class, the upper limit have to plus 0.5 become 120.5. Same thing happen for all the other classes. Okay, so after you get all the class boundary already, then you can get the class width. So for the class width, you can get it from the class boundary. You cannot get it from the class limit. Okay, 101 until 120 is class limit. So you cannot use it to calculate the class width. You have to use class boundary to calculate the class width. So to get the class width for the first class here, it will be 20. Right, so 125 minus 120.5 minus 100.5. Okay, so to draw the histogram, because we are having different class width, so first of all, I will want to list out all the different class width first. So what are the different, all the class width in my table? So the first class, like what I show you here, it is 20, right? Okay, so same thing happen for the second class. If I want to adjust it to class boundary, I'm having 120.5 to 130.5. So for the second class, this is the class boundary that we have for the second class. So to get the class width, you take 130.5 minus 120.5, where it is a 10. So the second class width is a 10. So please repeat the steps repeatedly for all the different classes here. Okay, until you get all the class width. So if you didn't do any class mistakes, right, by right, you should get all this as your class width. 20, 10, 5, 10, 15. Okay, so after you get the class width already, then next one we need to get the frequency density. When we are having different class width, when you want to draw the histogram, we need to ensure that our y-axis is actually frequency density. So how to calculate the frequency density? So just help you to recall back. Okay, so to get the frequency density, the formula is, usually you put it as FD, frequency density. So the general formula is actually frequency divided by class width. Okay, so we already get the class width for every single class already, right? Every single column in the table. So we can use the formula, okay, to find out the frequency density now. So for the first class, the frequency is 18. So to get the frequency density, I take 18 divided by 20. So 18 divided by 20, I got 0.9. Then how about for the second class? So the frequency is 48 divided by the class width, which is a 10. Therefore, the second class is having the frequency density 4.8. So again, you repeat the same steps for all the other classes until you get the frequency density for every single class. Right, so in your solution, please make sure that you show the answer for class width and also the answer for frequency density. Okay, so once we complete the calculation for frequency density, then we can start sketching the graph. So to sketch the graph, So first of all, my lowest class boundary is 100.5 and my highest class boundary is 160.5. Okay, so there are many ways that you can sketch your diagram. Okay, so for me personally, I prefer to draw all the classes, right, at the main line. So what am I going to do here is I'm trying to put the main line here as 100.5, which is the starting class boundary for my first class. First class. Okay. Then after that, I will want to make everything with 0.5 lah. Okay. So this one is 110.5 and so on. So let's see whether it fits or not. Should be no problem to fit into the graph paper. Yeah, so I think it's just nice, 116.5, right? So our x-axis is actually time in minutes. So you can write the label, the x-axis, time in minutes. Okay, then let's continue to the y-axis. So for the y-axis, right, we have to sketch frequency density. Okay, so the lowest value is 0.9 and the highest value is 6.8. So maybe I need to have it until 7. So I will label it like this, 1, 2, 3 until 7. And I already label my frequency density, okay, as the y-axis. Alright, so after that you can start sketching. Right, so to sketch first class is 100.5 to 120.5 with the frequency density 0.9. So 0.9 should be somewhere here. So until 120.5, right? So my drawing part might not be so accurate, so make sure that when you draw it, please draw it nicely, okay? Then after that, for the second class, I'm having the class boundary 120.5 to 130.5 and the frequency density is 4.8. Okay, so let me have a look where's 4.8. First will be here. Then I need to draw it until 130.5, which is this line. Okay, then I start creating the bar. So you can see that first bar and second bar is having different class width and therefore their width is different when you sketch the bar, okay, in the histogram. Then the third class. So for the third class, okay, is 130.5 to 135.5 and the frequency density is 6.8. So again, 6.8 is somewhere here and I want to draw only for class width of 5. So it should be something like this. So it is a very slim bar. Okay, so please repeat the same thing for the last two classes. Alright, then I'm having until 145.5 for 3.2. So 3.2 is here. 145.5 is somewhere here. Okay, then the last class is until 160.5 for 1.2. So 1.2 is slightly higher than 1 until 160.5. Okay, so by right, you can see that this is the how your histogram should look like. Alright, if you didn't do any careless mistake. Okay, right, so let's continue to part number B. What do we have for? Alright, so for part number B, they want us to calculate the mean and also the standard deviation of the time taken by the athletes. Okay, so to calculate the mean and standard deviation, if you can't remember the formula, of course, it is provided in the formula booklet. So this is the group data, right? So we're having group data. Okay, so mean formula and also the variance formula, right? So the x in the formula here means the midpoint of every single class. Yeah. So if we go back to our question, I need to find out midpoint for every single class first. Okay, so just now I get the class width already from the class boundary, and now to get the midpoint, I will need to take 100.5 plus 120.5 divided by 2 to get the midpoint. So for this case, the midpoint for first class is 110.5. So this is my x for the first class. So you have to repeatedly do the same thing for second class, third class, and so on to get all the midpoint first. Okay, right, so I will not show you every single class here, so just make sure that you follow what we have. Okay, in the first class, lower class boundary plus upper class boundary divided by 2. So this is how you get the midpoint of the graph. Okay, then after that, for easy reference, right, so I just want to write out the formula here. So for the mean formula, it will be the summation of fx divided by the summation of f. Then for standard deviation, the general formula, I'm using the easier one where it's summation of fx squared divided by summation of f minus the mean square. Okay, so we'll start the calculation for the mean. To calculate for the mean, I will need to take f multiply with multiply with the midpoint, right? So my frequency for the first class is 18. So please refer back to your original table. So the frequency for the first class is 18, multiply with the midpoint 110.5. Then you repeat the same thing for the other class, okay? Right, so I'm having 18, then multiply with the midpoint is 110.5. Okay, then plus second class frequency is 48, then the midpoint is 125.5, and so on. So I'll repeat this one for all the 5 classes. Okay, so I will write out my step like this, and then divided by the total frequency. So total we're having 120 at least, right? So you can directly divide it by 120. Hey, I don't think there's 120. Wait, let me have a look. Oh, sorry, it's 150. Okay, so not 120, but it should be 150 for the total frequency. Okay, then after that, you just try to use calculator and help a little bit to sum up all the value, then divide by 150, and try to find out the answer correct to 3 significant figure, or maybe try to check and see whether you're able to get a nice number or not. So I think if I'm not mistaken, when I take the fraction, right, simplify it, I'll get a very nice number, which is 131.9. So this is your mean. And then when I want to calculate the mean, right, basically you can see that I write out my step like this. So just now I didn't show the details of calculating the midpoint. Therefore, in my solution, you must show all this midpoint in your calculation. Okay, so some students say, can I just directly find out all the sum of frequency times x directly without showing all the midpoint? Cannot. You have to show the midpoint because it might be part of the method. Okay, so this is what we have for the mean. And now we want to continue for the standard deviation. Alright, so for standard deviation again, basically the steps looks almost the same. Okay, the formula is here, summation of fx squared. What does it mean? It means that you have to take the frequency, multiply with the square of x, so 110.5 squared. And then you add it for the next class, 48 multiply with the midpoint squared. So repeat the same thing for the other classes. Okay, so you can see that I repeat the same thing for the other classes, and then I have to divide it by frequency, also total frequency, which is 150 as well, minus the mean square. Okay, again, by using calculator to help you a little bit on the value, by right, you should get the number like this, 263.0272.5. Excuse me. Okay, simplify it. This should be your answer. Correct to 3 significant figure. Okay. Alright, so again, in your calculation for the mean or standard deviation, right, please make sure that you did show all the midpoints in the step of your solution. Alright, because usually they might give you one metal mark point here. Now we solve question number 4.
Okay, so now we are at question number 5. So we have a red spinner, then 4 sides with 4 sides, sorry, and then the score is actually the side that it lands. So X is actually the score. So they are giving us the probability distribution table like this. And you can see that from the probability distribution table that are given here, right? That's given here. You can see that the probability of getting every single score is different. That means this is not a fair spinner. Alright, so when x equals to 1, the probability of getting it is 0.28. So x equals to 2, the probability of getting it is p, and so on. So from here it can be seen very clearly that it is not a fair spinner. So now for the first question, they want us to find out the p. Want us to show that p equals to 0.12. Alright, so to show that p equals to 0.12, for any discrete random variable, right, we should know that the total of all the probability should be equals to 1, which means that you add up all the probability for every single score, and you should let it equals to 1. Okay, so add up together all the p and then bring the number over, you get 0.72, and from here you know that p is equals to 0.12. So this is a straightforward question. Alright, then let's continue to part number B. Okay, so for part B, now I have the other two spinner. I have blue and also the green spinner, and both of them are fair spinner. So that means no matter what score are you getting from these two spinner, they are actually having all the same probability. Alright, so each have the 4 sides labeled 1, 2, 3, 4. So that means to get any single score here from the spinner of blue and green, it should be 1 over 4. Okay, right, so because they are fair, so that means all the probability should be the same. Okay, so now all the 3 spinners, red, blue and green, are spun at the same time. So first of all, they want us to find the probability that the sum of the 3 score is 4 or less. Okay, so sum means that when you add all the 3 score that you get from a spinner together, then the value should be 4 or less than 4. Okay, so let us start. For this question, I think there's no single way for us to find out the probability directly in one step. So to be safe, it will be good if you can try to list out the possible result. So I try to list it out where I have R, which is the red spinner, blue, and also the green spinner. Okay, so to get the score for 4 or less, right? So maybe I start to consider it with score of 3 first, because less means that it should be maximum 4 or less than 4. So what is the possible score to get which is less than 4? There's only one possibility, which is 3. The total equals to 3. So to get the total equals to 3, it can be 1, 1, 1. Okay, so that means red equals to 1, then green equals to 1, blue equals to 1. So maybe some students say, why I cannot get the total equals to 2? Okay, it is impossible for you to have a total score which is 2, because it is impossible for you to get something like 0, 1, 1, right? There's no 0 score on a spinner. Alright, so the minimum score is 1 on a spinner, so the minimum total should be 3. So this is the first case. Alright, then how about the second case? So for the second case is you might have 1, 2, 1. Because 1 plus 2 plus 1 equals to 4. So that's the score for the 4. You can also have 1, 1, 2. So this is a total of the score, which is a 4. 1, 1, 2. And after that, I'm having 2, 1, 1, which is equals to 4 as well. Is there any other combination for you to get the 4 here? I think no more, right? So this is the only 4 possible cases, okay, for you to get the sum of 4 or 3. Okay, so just for your information, this one the sum is a 3, this one sum is the 4, this one sum is the 4, and this one sum is the 4, and no more other possible cases. Okay, so now I try to list out the probability here. So when red equals to 1, what's the probability for red equals to 1? So the red color equals to 1, you have to refer to the previous table. So the probability is 0.28. Okay, so please put in 0.28 here. Okay, and after that, how about the second probability here? Blue color equals to 1. So like just now what we told, what we know, all these are the fair spinner, right? So for all the fair spinner, no matter what score are you getting, the probability are always the same, which is 1 over 4. Okay, then for green color equals to 1, it is also 1 over 4. So if you want, you can just write 1 over 4 square. Then you get a probability here. Okay, then after that, for the second case, again, red color equals to 1. So red color equals to 1, the probability is 0.28 again. So 0.28. For green and blue color, they are still the same, which is 1 over 4. Alright, so 0.28, then 1 over 4, then 1 over 4. After that, for the third case, so for the third case, red color still 0.28 because it is equals to 1. So for the green and blue probability, they are always the same. Okay, for no matter what score are you getting, or no matter what score are you getting. And after that, for the last case here, your red color equals to 2. Okay, so if your red color equals to 2, right, what should you have? So the score, red color, x equals to 2, the probability is 0.12. So you have to use 0.12 and then 1 over 4 multiply with 1 over 4. Okay, so these are all the probability for us okay, to have when we are having we are calculating the probability. And after that, how can we get the final answer? So to get the final answer, what you need to do is you have to add your probability together. Okay, all right. So I will not list out the total for I will not list out the answer for every single cases here lah. But you try to total all this probability here. By right, it should be equals to 0.06. Okay, all right. So this is how we get the answer actually. So if you want to make your step become shorter, then basically you can write become something like this. You are having 3 times of 0.28 and then 1 over 4 square. Then plus 1 time of 0.12, 1 over 4 square. Alright, but of course, if you write out straight away like this, you won't see the details of the cases. So for me, basically, when you want to find the probability, right, there are some questions we can actually try to list out the cases so that you can see all the possible cases in a clearer way. Okay? Alright, so let's continue to part C. Okay, so for part C, now they want us to find out the product of the three score. Product of the three score is 4 or less. Then given that x is odd. Okay, so this question is slightly more complicated because of this one. Given that. So when you see the keyword given that, they are telling you about the conditional probability. Okay, so let me try to find out what is the probability that they want us to find first. So they said when you multiply all the score together for the 3 spinner, you get a 4 or less. So the word product tells you that it is the multiplication between the score, okay? So if you have 1, 1, 2, that means 1 times 1 times 2. Okay, so the product is 4 or less. And then given that x is odd, so x is odd means that the red color score must be an odd number. Okay, so for conditional probability, right, we have a formula in general. Okay, so when we're having something like A given that B, the general formula is A intersect B divided by the probability of B. This is what we have for conditional probability. Alright, so we have to apply this into our context of the question here. So now they say that the product is 4 or less, given that x is odd, which means that the numerator that we want to find, it should be product is 4 or less. Intersect with the x is odd, then divided by the probability of x is odd. Okay, so again, I need to list out the cases one by one again so that I can see clearly. Alright, so what are the cases included for product is 4 or less intersect with X is odd? So let us start. Maybe for me I will just list out the sides so that you can see it clearly. Right, so now I have red color, I have blue, I have green. So what is the combination that we should have so that the product of the three score is 4 or less? Okay, so maybe we start from score equals to 0 first. The product equals to 0. Sorry, product equals to 0. Product equals to 0. Is it possible for us to get any score? Product equals to 0. Impossible, right? To get a score, product score equals to 0 should be something with 0. So you cannot have 0, 1, 1, right? So we have no 0 score on the spinner. Okay, then how about to get the product equals to 1? So to get the product equals to 1, very obvious, the 3 score here, all of them should be equals to 1. Okay, so no other cases. So 1 times 1 times 1, you get a 1. Okay, then let's proceed to a higher score. So how about if I want to get the product of 2? So to get the product of 2, it must be 1 times 1 times 2. Okay, and then for this, you can also consider it as 1 times 2 times 1. Also give you a product score equals to 2. Then you have also 2, 1, 1. Right? Okay, then after that, what else? Is there any possible score multiplied together to get a product equals to 2 or not? No, right? Okay, so the 2, 1 settle. Then let us continue to the product rules, the product of the score equals to 3. Okay, so for the product equals to 3, you might have other cases, right? Okay, so you have 1, 1, 3, 1, 3, 1, and then 3, 1, 1. Okay, any other thing else? I think no more. So then how about for the product score equals to 4? So for the product score equals to 4, you will have 1, 1, 4, 1, 4, 1, and also 4, 1, 1. There are many cases, right? But just be patient. It is easier for us to visualize it easier. Okay, so just now we are at the product score equals to 4. And then besides 1, 1, 4, right, you might also aware that if I have 1 multiplied with 2 multiplied with 2, it will give me a product score equals to 4. So I also can have 1, 2, 2, 2, 1, 2, and also 2, 2, 1. Okay, then what else to have the product score equals to 4? I think no more. Okay, and after that, we no need to proceed to the 5 because according to the question, they're asking 4 or less. So we already consider score equals to 1, score equals to 2, and so on until the 4. Okay, so after I list out everything possible already, then now let us go back to the question itself and see what we actually need. So for the question, you can have a look that they said, okay, the product is equals to 4 or less, but at the same time, intersect means at the same time, right? The X is odd. X means the red color spinner is an odd number. So we already list out everything just now. So let us go through again to make sure that is it our outcome here fulfill what we want here. The product is 4 or less at the same time or intersect with red color is an odd number. So first case, red color is the odd number, no problem. Second case also the same. Third color also the same. Third case also the same. For the fourth case here, you can see that the red color is not an odd number. So I actually don't want to consider this case anymore. Alright, so it shouldn't be included in our calculation for the numerator. Okay, then fifth case, red color odd number, correct? Odd number, correct? Odd number, correct? Then where else? So these two also correct. And again, this one you can see that the red color is equals to 4, which is not an odd number. So I don't want the case anymore. Then continue further. Okay, so this one, red color is odd number. These two, the red color is equals to 2, which is not an odd number. So I also remove it from our consideration. Alright, so eventually, this is all the possible cases for us that fulfill the case where product is 4 or less intersect with the odd number. Okay, right, so let us move it slightly higher. Okay, then now again, you can start to calculate the probability for every single case here. So when red color equals to 1, so go back to your first case again just now, the first table, when x equals to 1 or red color equals to 1, it is equals to 0.28. Okay, so you continue further, this one is 0.28. Alright, and then how about the other two? So the other two is actually 1 over 4 multiplied with 1 over 4 lah. So for me, I want to actually simplify become 0.25 square lah. Alright, so it's 1 over 4 multiplied with 1 over 4. So how about for this one, the second case here? So the second case here is also the same, 0.28, then 0.25 square. The third one also the same when the red color equals to 1. So all of them are having the same probability. Okay, so all these are the cases where the red color spinner equals to 1. Okay, then when the red color spinner equals to 3, what is the probability? So equals to 3 means 2p. So 2 times 0.12, you get 0.24. So go back to this case, you're having 0.24 multiplied with 0.25 and then square. Then this one is again 1. Okay, the red color equals to 1. So the first probability should be 0.28. This one also 0.28. This one also 0.28. Okay, so to simplify all this calculation here, you just count how many probability are the same here for 0.28 multiplied 0.25 square. So 1, 2, 3, 4, 5, 6, 7, 8. So there are 8. You can write it like this. So 8 multiplied with 0.28 with 0.25 square. Then add another one which is 0.241, right? Okay, and then divided by the probability that the red color spinner is odd. Okay, so how to calculate the red color spinner which is odd? So again, you come back to the table again. The odd score is 1 and also the 3. So 1 is 0.28, 3 is 0.24. So you just put it under the denominator in the fraction. So 0.28 plus 0.24. Okay, then just simplify the answer by using calculator if you want. So by right, you should be getting a fraction which is 31 over 104. Or you can change your answer correct to 3 significant figure which is 0.298. Okay, alright, so basically this is how we get the answer for question number 5. Okay, so now let's discuss question number 6 for this paper. So we are having in a restaurant, right? There are 2 tables here which are rectangle, and then each of the table can sit 4 people. Right, so we are having 8 friends in total, and then there are 3 special name one RST okay, Rajit, Sue and also Tan are 3 of these friends. So the 8 friends will be divided into 2 groups of 4. Divided, maybe highlight the keyword divided here. 1 group for the table X and also 1 group for the table Y. Okay, and then now they are saying that the R and S, Rajit and Sue must sit at the same table. Then the other table, T must be sitting at the other table, Tan must be sitting at the other table. Right, so for this question, you need to highlight the word divided. So divided means that actually give you an idea that we are going to choose the people and put them into groups. Alright, so the sequence of choosing people is not important. Right, so for this question, basically it is about combination. Right, okay, because they didn't mention like where the friends should be sitting and so on. They just want to divide them into 2 groups only. Okay, so okay, let's talk about the first case. So if let's say Rajit and Sue must be in the same table, right? No matter where they sit, okay, it is not important that where they sit. So I just know that both of them must be in first table, and then T must be in second table. So we fix them directly first into 2 different tables. Okay, so we fix them separately first, right? Because this is a restriction, so we just write out, okay, or fix them into the table first, respectively here. Then only we consider how to choose the remaining 5%. So you still have remaining 5%, right? Remaining 5 friends. So for this remaining 5 friends, you want to separate them into 2 groups. So one group is with 2 people to put it into the X, one group with 3 people into the Y. So your calculation should be something like this. It should be 5C2. That means from 5 friends, you want to choose 2 of them and put it into table X. And then the remaining 3 automatically into the table Y. So this is 5C2. So maybe some student will say, I want to put 5C3, can or not? Also can. So that means if you put 5C3, that means you are putting them into the Y, then the remaining 2 automatically are into the X. So no matter you put 5C2 or 5C3, basically the answer is the same. Okay, alright, so for me, I'm using 5C2 lah. So 5C2 means that I choose 2 person and put it into table X first, then the remaining 3 into the table Y. Okay, but this is one case. We also have the cases where maybe Rajit and Sue, right, they are actually sitting at table Y and then T at the table X. So for this case, 5C2 means that you choose the 2 person and put it into table Y, then followed by the remaining 3 person into the table X. So there are 2 cases here, therefore I multiply it with 2. Okay, so for this question, by right, you should be having answer 20. Alright. Okay, so let's continue to next part. Okay, then now they are saying that when the friends arrive at the restaurant, so Rajit and Sue decided to sit at table X. R and S sit at the table X on the same side as each other. So highlight the keyword same side. Okay, as each other. Then Tan decided that he does not mind at which table he sits. So find the number of different seating arrangements. So now highlight the keyword arrangement. So this tells you that for this particular question, it is a permutation question, which means that the sequence is important. Alright. Okay, so for the arrangement here, so how should we arrange first? Usually we will start with the arranging for the restriction. So our restriction here is actually Rajit and Sue. They must be sitting at table X and then same side as each other. Okay, so from here you can see that for Rajit and Sue must be sitting in table X, right? Same side. So either they sit like this or either they sit like this. So this is the first option for R and S. This is the second option for R and S. So for our first number here, there are 2, right? So you can multiply it with 2 because you have this side of the table or that side of the table, so you have 2. Multiply with, you need to consider the sequence, the sitting between the R and S. Maybe R can sit on the left, S can sit on the right, or the other way around, where S can sit on the left, R can sit on the right. So this one you have to multiply with 2 also, or I can write as 2 factorial. Alright, okay. So after you place them in the table already, so let's say they are sitting at this side, huh? Okay, so for the remaining 6 person here, you can arrange them freely. You have 6 space or 6 seats, and you want to arrange 6 people inside, so by right it should be 6p6, or you can write as 6 factorial. Okay, because T now no longer care what's the table that he need to sit. He can sit anywhere, right? So you just arrange them like normal people. Okay, so you can straight away arrange all the 6 people together. So 6p6 or 6 factorial. So multiply it with 6 factorial. Okay, so by right you should have 2880. Okay, alright, so this is how we solve part B. And let's continue to part number C. Okay, now, as they leave the restaurant, they want to stand in a line for a photograph. Find the number of different arrangements. Okay, highlight the keyword arrangement again. So this is about permutation. So now Raji and Sue must be standing next to each other, but they don't want to stand at the end of the line. Okay, so this is another restriction. But because of this restriction, they don't want to stand at the end of the line, right? So we have to arrange them lastly so that they will not be at the end. Okay, so first of all, I try to arrange the remaining 5 friends with Tan first. So I arrange 6 of them freely. So I'm having 6 factorial. Okay, then now to make sure that Rajit and Sue are standing next to each other, right, I will actually put them into one unit. So I assume that they are one unit, okay? So to put this one unit between all these friends and to make sure that they are not at the end, so I will just fix that they can stand here at the arrow side. So you can see I won't put my arrow outside, because if I put my arrow outside, right, then Rajit and Sue will be standing at the end. So the side one cannot be included as a position or place for Rajit and Sue. So if you have a look for the number of arrow here, there are 5 spaces available for Rajit and Sue. So you multiply it with 5. Okay, so after you place Rajit and Sue in any of the space, right, you also need to consider the arrangement between them. It can be Rajit Sue or Sue Rajit. So you have to multiply with 2 factorial. Okay, alright, so I think this is how we consider the case. Alright, so by right, if you didn't do any careless mistake, it should be 7,200 for this arrangement. Okay, alright. Yeah, so this is how we answer part C and answer question number 6. Alright, so I think this is the end for the paper. Alright, so thank you very much for watching the video.